evidence is
after the equation of the trend line, the
that
next
you've
level up is
collected in the
modeling.
Mathematical modeling is where you actually put in what variables are on your x and y axis. You can look at other
answered the
videos for how
question
to do that.
And that also requires scientific data to validate that it was a good mathematical model.
Because you can make a mathematical model out of just about any equation, but how do you know if it's good? Well, that's what this value is
specific.
Very concrete.
One of the best things you can do after the mathematical model, which is awesome to produce, is using percent error.
Some labs you'll have a known value. For example, you might know acceleration due to gravity is 9.8 meters per second squared, which is generally me, that we got a 2% error, producing we got a value of 9.6 that backs up your claim. So if you're going to say that velocity is directly related to time, then what evidence do you have for that? Do you have a graph?
Up your claim?
Do you have so sometimes a lot of labs we do numerical
we don't
values
have a percent
error.
error.
You can't do that's not even an option. Do you have a percent error that maybe we want to look? Can I do a mathematical model? Like any of those things,
can I do the equation
of the trend line? You only need one piece of evidence. That should be the absolute best piece of evidence. So you always want to use the most sophisticated evidence that you have. So what do I mean by that? So I'm going to give you a hierarchy of evidence so you can see what I mean. Okay, here's my hierarchy of evidence. So we start out with the most basic evidence. This is generalization, right? When velocity gets bigger, time gets bigger, right? There's nothing specific, it's very vague, it's a broad generalization. The magnetic field gets stronger when when we added more magnets to the motor, something like that. So generalization, it can be quantitative or it can be qualitative, and it's very low level. This is stuff that you've done like in middle school, elementary school, very qualitative, very generic, okay? The next level up is specific data points. So you might say in trial 1, when time was 1 second, we got a value of 3 meters per second, and for trial 2, when time was 2 seconds, we got a value of 20 meters per second. Those are using specific data points. Not all that great because it's just 2 instances that validate your claim as opposed to any kind of general trend or maybe 20 points that validate your claim. Then you've got a trend with simplified error analysis. So you could say, you can see from my data table, right, that that there's an increasing trend, and when I did simplified error analysis, I got my range to be much greater than my error, and you want to present those numbers. So I'll teach you how to do simplified error analysis, or you can look back at your notes to see how to do that. That's like another level up because you're using more of a trend, right? You're looking for generic, but again, it's something that is backed up with some concrete evidence. You can use a graph shape. So you made a graph, you've got some kind of trend line, and you can describe it. I got a linear fit for my trend line. Right? That's another level up. That's better than what's before it, right? So it's a bit better. After the equation of the trend line, the next level up is mathematical modeling. Mathematical modeling is where you actually put in what variables are on your x and y axis. You can look at other videos for how to do that. And that also requires your correlation coefficient to validate that it was a good mathematical model. Because you could make a mathematical model out of just about any equation, but how do you know if it's good? Well, that's what this value is for. And then one of the best things you can do after the mathematical model, which is awesome to produce, is using percent error. Some labs, you'll have a known value. For example, you might know acceleration due to gravity is 9.8 meters per second squared, and we got a 2% error, right? We got a value of 9.6 meters per second squared. Like, that's really good evidence that you did a good job at the lab and that you got a good value, and it will back up your claim. So sometimes a lot of labs we don't have a percent error. So you can't do, that's not even an option. So you want to then look, can I do a mathematical model? If not, can I do the equation of the trend line? You only need one piece of evidence, but it should be the absolute best piece of evidence that you've got.